Hello everyone, my name is Po-Cheng Hsieh, and I'm a student from the National University. And my advisor is Dr. Yan Fu. And today I'm going to introduce my research, which topic is observing behaviors of Weaning piglets in nursery using Hsieh. And this is my outline. I'm going to start with the introduction. The motivation behind this research is the economic significance of the pig farming industry. In 2023, the global farming industry had a total production value of about $258 billion, accounting 7% agriculture and 17% in animal husbandry. And after introducing the economic value of pig industry, let's briefly discuss the pig rearing process. The process is mainly divided into 3 stages: farrowing house, nursery, and finish house. And this research was conducted in nursery stage. And at this stage, farmers usually focus on the exercise and activity of piglets, ensuring that piglets are healthy and in good condition. However, farmers encounter some problems during the rearing process. Since the nursery piglets will come from different farrowing crats and sows, so they are introduced to a different and unfamiliar environment and companions. This unfamiliarity often makes piglets nervous and sensitive, leading to a significant increase in aggressive behavior during the first week. The aggressive behavior can manifest as fighting, biting, or even bullying. This behavior can lead to various negative health conditions such as stress, immunosuppression, injury, inflammation, and growth retardation. A piglet subject to aforementioned problems is called weak piglet. Weak piglets are usually characterized by the reduced appetite or activity. Without intervention, such piglet may experience a severe growth retardation or even die. Moreover, this leads to unbalanced pig sizes, making it difficult for farmers to move the entire plant to the next stage. And this discrepancy poses a huge challenge in farm management. To address these problems, conventional practices involve farmers conducting regular observation by patrolling the nursery throughout the day. Diagnosing the health of piglets relies heavily on farmers' experience and expertise. However, since each farmer's experience varies, the standards for diagnosis are not uniform. So I think the conventional method is time-consuming and subjective. Moreover, the pig industry found it more difficult to recruit new employees in recent years, making lab shortage a big problem too. So my objective is to develop a system that can automatically observe the piglet behavior and assist farmers with farm management. And next is method. And this is my system pipeline. There are 2 deep learning components and image cropping process. And the system finally output the feeding, drinking, and aggression time, as well as the movement. And video acquisition was conducted at a commercial pig farm in Taiwan. And each video was 1 minute long, with frame rate of 5 ps, and recorded from 9 a.m. to 5 p.m. The collected videos will underwent the perspective transformation to remove the irrelevant spatial content, which included rotating and scaling. And the corrected image can be used as the data set of the piglet detection model. And next is piglet detection model in tracking, which referred to as PDMT. And there are 560 label frames in data set of PDM. The labeled classes included individual piglet and interactive piglets. There are 448 frames for training and 112 frames for testing. And the YOLO V7 has been selected as its model architecture. And this is the training details. After training a PDN is combined with the sort algorithm, or planning to check the piglets in nursery. And this is the architecture of the sort algorithm. And next is image cropping. Image cropping was applied to discover the potential feeding, drinking, and aggression events. In this process, we need the position of the feeding bucket, drinker, individual piglet, and interactive piglets. Since the position of feeding bucket and drinkers are fixed, so I define the feeding area and the drinking area with fixed coordinates. And the position of individual piglets and interactive piglets were detected by PDN. After obtaining the position of this object, the position of individual piglet can be used to calculate the IOU with the feeder or drinker, thereby discovering the potential feeding or drinking events. And the position of interactive piglet can be used to discover the potential aggression events. After finding out the potential event, the corresponding image and its next door image will compile into a clip. These clips can be used as the data set of the piglet behavior recognition model. And next is the piglet behavior recognition model, which is referred to as PBIMS. And in this research, there are 3 PBIM: feeding PBIM, drinking PBIM, and aggression PBIM. And each PBIM has 2 categories, making a total 6 categories. And this table shows the data set of each PBIM with each data set divided into an 8:2 ratio. And the CIN has been selected as its model architecture. And this is the training detail. And next is the result and conclusion. The performance of PDN, which achieved a MAP of 94.5%, and this is the result of prediction. And this is the performance of tracking, which achieved a MOTA of 83%. And this is tracking. This is the result of tracking. And this is the performance of PBIM, which achieved an overall accuracy of 93%. And this table shows the performance details of each PBIM. And next is the long-term analysis of piglet behavior in this study. There are 4 batches, 2 for one season, represented by the blue and the green, and 2 for the cool season, which represented by the red and purple. And each observation period lasted for 35 days, and with 20 piglets per batch. From the top left to the bottom right, the graph respectively shows the duration of the feeding, drinking, aggression, and movement. And next, this image shows the daily average duration of each behavior for each batch. We can more clearly to see the differences in behavior duration between batches. And I will explain the behaviors one by one. And this is analysis of feeding behavior. And from the figure on the left, after the first week, the feeding behavior gradually stabilized. And let's look at the figure on the right. Now we can observe that the feeding duration during the warm season is less than the cool season. It indicates that the feeding behavior is related to the temperature and season. And this is the analysis of drinking behavior. After the first, from the figure on the left, after the first week, the drinking behavior gradually stabilized. And let's look at the figure at the right. The drinking duration during the warm season is higher than the cool season. It indicates that the drinking behavior is also related to the temperature and seasons. And next is an analysis of aggressive behavior. From the figure on the left, we can observe that there are lots of aggressive behavior happen in first week and gradually decrease over time. This aligns with what I mentioned in introduction. The piglets usually have more intense interaction during the while adapting to the new environment. And let's check the figure on the right. We can observe that the relationship between the aggressive behavior and the seasons is less apparent. And that is an analysis of the movement. From the figure on the left, we can see the movement is higher on the first day. That is because the piglets are being transferred from the farrowing house to nursery. And after that, the movement gradually stabilizes. And let's check the figure on the right. We can observe that the movement in winter, which is represented by purple, is less than other batches. It is quite confused to me, so I reviewed the video during that period and tried to discover something out. And I discovered that during that period, there are lots of instances of overexposure. And it caused a problem with the system checking the piglet, leading to the abnormal movement observed in this page. And this is my conclusion. Pig detection model achieved an NAP of 94.5%, and the performance of checking achieved MOT of 83%. And the overall accuracy of piglet behavior recognition models have reached 93.3%, and the piglet behavior is highly related with season. And thanks for listening.
We have time for one question.
Yeah, so for that tracking, were you able to track individual P in the nursery all the time?
Yeah, just checking the.
They look all the same to me.
Yeah, we don't identify the piglet, but we check all piglets in the pen and to calculate the all movement of the piglet. So there's no ID on the piglet.
Okay. Thank you.
That's good. Thank you.